I have a confession to make, guys. I told you months ago that when I built a crazy, over-the-top, $10,000 plus computer, that I would actually use it. And, well, I haven't not used it, but I'm not completely using it either. This video is going to be about actually making use of Riptide.
Excellent!
The Corsair One is a gaming PC for people who want maximum performance with a minimal footprint. Don't let the size fool you though, there's a Core i9-9900K CPU and an RTX 2080 Ti in the Corsair One i160, kept chilly with convection-assisted cooling and separate closed loops for the CPU and GPU. There's also a Corsair One i140 with an i7-9700K and an RTX 2080, so click the sponsor link in the video description to learn more.
So I'm in the computer room today, and Hero is chilling down there below me, so if you hear him snoring, it's okay, he's peaceful and nice down there. But Riptide, I built a stand for it. I did a multi-part video series on it last summer, from the inception to the construction to the water cooling to the upgrades in the future. A ton of work gone into setting up the RGB lighting on this system, and I'm really happy with how everything turned out. And I was pretty much ready to start using it, except I wanted to make this video about using it. So there was certain setup stuff that I didn't do with it completely, like setting up the RAID, because I was waiting to make this video. At the same time though, I make lots of videos, and I have this other computer behind me that I had previously set up to render all my videos and do editing and stuff like that, and I kept relying and reverting back to that just to get work done instead of completely switching over to Riptide. So today I have 3 demos that I'm going to share with you guys. The first is going to be a setup demo for that RAID storage configuration. I have a bunch of SSDs. It's actually all SSD storage on the upper system in this build, since there's 2 actual systems in there, including a FreeNAS. So I need to figure out how exactly all those are going to be configured, set up the RAID configuration, maybe do some quick testing on that too to see how fast the drives actually are. Second is going to be a more practical demonstration of rendering a video on this system, Riptide, versus the old system back here, which by the way has a 7820X and 32 gigs of DDR4 memory. And then the third one, as always in these types of videos, I want to play some video games. And since this system has 2 1080 Ti's in water-cooled configuration and SLI, I'm going to play some games on those 2 at the end in 4K at, well, 60 Hz, because I've got 4K 60 Hz monitors here behind me. Before any of that though, if you guys don't want to go back and watch the old Riptide videos, here's a quick recap on the hardware that is actually installed there. So the system was mostly built around the case, which is the Corsair Obsidian 1000D, which is the largest and most elaborate case that Corsair has ever put together for mass production. It has tempered glass everywhere, and it fits 2 systems, one in the top part and one down in the bottom part that can be a mini ITX system. So the mini ITX system at the bottom I configured as a NAS. It is actually running FreeNAS, and it's based on an AMD Ryzen 5 2400G processor that has a Vega 11 GPU integrated. The cooler is a Noctua NHL12S low-profile cooler, and the motherboard is an Asus ROG Strix X470-i Gaming. For memory, it has 2 16 gig sticks for 32 gigs total of Corsair Dominator Platinum DDR4. I am potentially going to be switching this out for ECC memory at some point in the future, but I haven't gotten to that project yet. For hard drives for the NAS, we have 4 8TB WD red spinning mechanical hard drives, and those are down in the lower bay. This case can actually only fit 4 standard 3.5-inch mechanical drives in its default configuration, so I maxed out that space with all 4 drives for 32 terabytes total in the NAS. FreeNAS is then running on an Intel Optane 32 gig SSD that's installed in an M.2 slot, and then I have a Corsair Force MP500 120 gig NVMe SSD, and that is running as a cache drive for the FreeNAS setup, and there's a separate video on the FreeNAS setup if you want to check that out. Lastly, the power supply for that system is a Corsair SF600 SFX power supply. Power supply for the big system is a Corsair AX1600i 1600 watt 80 plus titanium rated power supply. Going down to the rest of the specs for the upper system, we have an Asus Zenith Extreme X399 motherboard, a AMD Ryzen Threadripper 2970X, that's the 24-core, 48-thread Threadripper CPU. It's not the 32-core version, but 24 cores and 48 threads are still plenty enough for me. There's about $500 worth of fans in this system, all Corsair LL Series 120 and 140 millimeter fans that you can see across the front, as well as the back and the top radiator. For memory, there's an absolutely insane 128 gig kit of Corsair Vengeance RGB. That's a DDR4 3200 rated, although I have been having some trouble running it at that rated speed. The graphics cards are dual Asus ROG Strix GTX 1080 Ti's. Everything that is water-cooled is pretty much water-cooled by Alphacool. The GPU blocks, the pumps, the rads, the reservoirs. Only thing that's not is the monoblock that's on the motherboard. That is from EK, the specially designed monoblock for the Asus Zenith Extreme. And lastly, there is the storage in the separate drive, and this is where there's a lot, and there's several things that have been added over time. For the main operating system drive, I'm running off the Corsair Neutron NX500, which is a 400 gig PCIe NVMe SSD, which is kind of tucked in there between the graphics cards. For additional fast storage, I have two Samsung 970 EVO 1 terabyte NVMe SSDs, and those are on the little riser card that Asus provides called DIM.2. There's a couple 2 terabyte SanDisk Ultra SATA SSDs. There's a couple 480 gigabyte Corsair Force LE SATA SSDs, and then there's a Corsair Force MP500 960 gig M.2 NVMe SSD that's installed as well down in the actual M.2 slot on the motherboard. So altogether, I've got about 7.5 terabytes of SSD storage in this system, some SATA, some NVMe. A lot of it is very, very fast. Some of it I'm going to be configuring in RAID 0 configurations, and some of it I'm just going to leave as is. For long-term storage, I'm going to be transferring everything over the network to the FreeNAS, and then I still will probably be using long-term storage by copying stuff to external mechanical drives like I have right here. I've been doing that for way too long though. I need a better solution. Let's set up some RAID. Most of the RAID setups I've done are on Intel systems. This is an AMD system. There are some slight differences. Fortunately, I've pulled up a quick setup guide over here, so I'm going to be hopefully diving through that to figure out what the heck is going on. First thing we're going to need to go is go to our SATA configuration. This is what I'm already aware of, and switch from AHCI to RAID. That should allow us to set up RAID for all of our SATA connected drives, the 4 SSDs, 2 500 gig ones, 2 terabyte ones. Next up, over here in the advanced tab, we want to head down to AMD PBS, and we're going to switch NVMe RAID mode to enabled, and that will help us too. The instructions also have some information in the AMD CBS tab, but that's not there anymore, and it does seem like our SATA controller is enabled, so the funny thing about this guide is it's made for the standard UEFI BIOS settings, but Asus has gone in and, moved some things around and changed stuff to their preferences. So I basically found everything from this guide that I could and changed it, and then I just went through all of the other advanced options and I looked for anything related to SATA or CSM, and I changed everything that I think should have been changed. Oh wait, look, there's CSM. CSM support should be enabled. All right, well that's good. UEFI and Legacy, that's good too. So these settings look good to me. I'm going to save changes and reset, and then there should be a pre-boot environment that I can get into by pushing a shortcut key. That's usually how this works. All right, well, as I sort of feared, the RAID setup was a bit more confusing than anticipated. Fortunately, I've made my way through it with some help, some outside help. I want to give a shout out to Go Step Film Pro, who posted on the Asus ROG forums a walkthrough of a situation very similar to my own. That was really helpful. And also Eber Anthony from Hardware Canucks. He did a video back in 2017 where he went through the RAID setup process. I think he got some help from Wendell from Level 1 Techs as well. So thanks to all you guys. By referencing those materials, I was able to figure out pretty much what was going wrong. After going through the UEFI and trying as hard as I could to find all of the RAID and SATA and NVMe configurations things that I could, I didn't find them all. I was able to set RAID mode for the NVMe drives as well as for SATA, but for some reason the utility that you're supposed to be able to access from the UEFI just was never there. I'm running the latest version of the Asus Zenith Extreme BIOS and everything, so not sure what the deal was there, but managed to get it figured out from within Windows 10 and mostly by using Device Manager. When it comes to your drivers for the devices, you're going to have drivers for the disk drives themselves, and you're also going to have drivers for the storage controllers. I basically had to download AMD's SATA RAID driver software, and then I had to go through in Device Manager and either re-recognize or update the drivers for all of the storage controllers to make them AMD RAID bottom devices, because, who doesn't want to be a bottom? And then also the disk drives themselves, not for the SATA drives, but for the NVMe SSDs. After doing all that, going through a system restart, I was then able to install the actual utility, which is called RAID Expert 2. That wasn't initially installing because it was giving me an error saying I booted it off an NVMe drive, so running that software would break it and then I wouldn't be able to boot anymore. Fortunately, going through the other stuff first allowed me to do this once I did that, it went through the installation after hanging for a little bit, and then I was able to launch up this web interface, and this gives us, fortunately, a layout of all the drives. So we can see our Corsair Force LE drives, we can see our SanDisk 2TB drives, we can see the Force MP500 and the Neutron NX500, as well as the two Samsung 970s. So all of our drives are here. That's really good. We can see the drives I'm already using. The Force MP500, disk 5 has already been assigned drive letter E, and then drive letter C has been assigned to the Neutron NX500, the 400 gig version of that, because that's what I installed Windows onto. So we have 3 RAIDs to set up, and I think I'm just going to go RAID 0 with everything. Max speed. I'll have all my data backed up elsewhere, so I can let's just see how fast these can be. All right, so first thing I'm going to do is initialize all the drives that are not currently initialized. That is my SanDisks, my Corsairs, my Samsungs. Let's go ahead and initialize. Yeah. Next, let's create a RAID array. I want to do a RAID 0. I want to select I got to select the disks up here. Just name this 1 terabyte Force LE RAID 0. And then we'll just repeat that process for the other drives as well. These other SATA drives are SanDisks, so this is going to be a 4 terabyte SanDisk RAID 0. And one more with our NVMe drives, Samsung 970s. This will be a 2 terabyte Samsung 970 RAID 0. Look at that. It's gorgeous. All right, so my arrays are created, but we're not going to be able to view them in Windows quite yet. We can still only see those first 2 drives. We need to go over to disk management, and then we should be able to, oh, there we go. We can initialize those 3 new disks which have been created. They're virtual disks created by the RAID arrays. We'll go ahead and let it do that for all of them, and then we'll just create partitions on those 3 drives too. Alright, so my storages should now be configured, and there they all are. 1 terabyte Force LE, that's 2 480 gig drives, that's just a 960 gig. The 4 terabyte SanDisk RAID 0, 2 terabyte drives, and the 2 terabyte 970 EVO NVMe RAID 0. Look at all that space. So much room for activities. Let's see how fast these are. So here's some quick test results with Crystal Disk Mark, going and testing my 3 RAID arrays. So starting on the top left is the D drive, which is the 2 Corsair Force LE 480 gig SSDs. We're getting about 1100 megabytes per second reads, and just a little bit less than that when it comes to sequential writes. So good performance. That's what you would expect from 2 good SATA SSDs put together in RAID. IOPS are over here on the right as well, if you guys want to check those out. Next up is the F drive here, which is the 2 SanDisk 2 terabyte SSDs that are in RAID 0. These are still SATA SSDs, so we're seeing real similar performance, close to 1100 megabytes per second reads, just shy of 1000 megabytes per second write. So the write speed here is a little bit slower, although it was a little bit faster in some of the 4K tests, which are down here below. Again, IOPS are here on the right side. Overall, got a little bit higher score than the 2 480 gig drives, but finally we have the big jump up from the 2 Samsung 970 EVOs, so 5855 megabytes per second reads, just over 5,000 megabytes per second rates. Real good performance. IOPS over here on the right. This is a little bit less than you'd see with the utility like Iometer, which you can sort of use to find the perfect range to get maximum IOP performance. But also, since we're looking at a RAID configuration, there's going to be a little bit of overhead there as well, so that will hurt overall IOPS performance too. So what I'm not 100% sure of right now is whether this is going to do me a lot of good, these massive sequential read and write numbers here. Given that the 4K numbers aren't all that much better than a single SSD, I might just go with those 2 individual rather than combined together, but we'll see how that goes in the future. Finally, I did a test on the standalone NVMe drive. That's the Corsair Force MP500, so this is a just M.2 NVMe SSD by itself, just shy of 2,500 megabytes per second read speed and just over 1,500 megabytes per second sequential writes. IOP performance is down here as well. We can see it wasn't too far off of our dual Samsung 970 EVO configuration. So my next test is actually the most important one as far as actually using this system, because it's rendering. Rendering with Adobe Premiere, which is a software that I use to render most of my videos. By the way, there is gardening going on right outside the window. I apologize, but I have to do this because there's actually a test going on right now. My test is side-by-side rendering on both systems to see how much faster Riptide is than the old system I'm using before, which again uses a 7820X, so it's got 8 cores and 16 threads. We're dealing with 3 times the amount of cores and threads on Riptide, 24 cores and 48 threads. So maybe that means it will be 3 times as fast. Long story short, yes. Pretty much. Let me quickly talk about the tests as set up because it's actually still going on the system on the left here. It has finished on Riptide with a time of 9 minutes and 23 seconds. What I am actually doing is encoding a 4K video, 3840 by 2160 at 29.97 FPS, progressive scan H.264 encoding with a target bitrate of 42 megabits per second. And we're still rendering on the system on the left, so I'll have to tell you what this ends up being, but it's already been going for over 20 minutes, and again, this one on the right finished in 9 minutes and 23 seconds. While that's still going though, I'm going to talk about the UEFI settings on Riptide because that's one of the things that kind of took me the most time to get figured out, specifically memory. We have 128 gigs, 8 DIMMs of memory, and with Ryzen it can be challenging to get your memory to run at a faster speed. The memory is rated for 3200 speed. I ended up deciding to dial it back to 2933, which is still a good speed for Ryzen. Let's take a quick look at what I did in order to get those settings. Actually, before I close this, let's talk about the actual performance while it was rendering. Across all cores, it was running at 3.5 gigahertz, a little bit higher than 3.5 gigahertz. It's actually going up to 4.1.5 gigahertz on a single core at a time, so it's getting nice single core performance in there as well. But 24 cores at 3.5 gigahertz, and that's just with the stock frequency. That was super nice. And then when it comes to temperatures, it was running in the high 40s, maybe hitting the low 50s from time to time. It peaked at 55.8 degrees Celsius on the die, so that's very good temperatures there, again, with so many cores and threads going in the same system, so that was pretty cool. Our memory usage peaked at about 38 gigabytes, so still plenty of headroom available there. Now let's dive into the UEFI settings though. Yes, my old system is still working on that render, but here's a quick look at my UEFI settings in Extreme Tweaker. I'm leaving most stuff at auto because I didn't want to mess with the CPU overclock too much. I was originally trying to hit that higher DDR4 frequency of 3200, ended up dialing it back to 2933. I might still push for 3000, but 2933 really isn't that far off from there. Beyond that, I went with manual settings for the SoC voltage as well as the DRAM voltage, and then in the DRAM timings, I did loosen them up, so we're at cast latency 17 right now. Well guys, the old system finally finished rendering that project out with a total time of 27 minutes and 37 seconds, which is right about 3 times as long as Riptide took, so I guess that's the result right there. With more cores and more threads, you get faster rendering with software that takes advantage of all the cores and threads, of course. Now, in case you're wondering, the right panel here is, for one, a TN panel. It's not as nice of a panel as the panel on the left. I actually have both of these set up so I can sort of compare and contrast one to the other when I'm looking at my work. I have a nicer, high color depth IPS monitor on the left. I can also bring it over to this not quite as good of contrast monitor on the right to see what it might look like for people who don't have monitors that cost more money, but it's also running at 1080p, and that is because I am passing it through my notebook down here in order to capture the stuff I've been showing you on screen with the UEFI BIOS and the tests I've been running. Now, the last part of this video is going to be gaming, and I'm just going to play some games, show some stats on screen, and share a few clips of those with you guys, because I just want to play some games on this system. But before I get to that, I wanted to talk about pros and cons now that I've had this system set up and been using it for a little while. Pros are, of course, all of the awesome stuff that you guys have seen. The system itself, it looks awesome. It's quite pretty, I think, with the LEDs, the custom sleeve cables. I really like this sort of stand that Joe and I built for it, which turned out really nice, I think, as well. It kind of keeps it up off the ground, but at a level where I can still get a view at it, especially those pumps. The fact that I can see the water flowing in the pumps as I'm using it is just nice peace of mind for me, because I've had pumps die on water-cooled systems before, and that's something I want to keep an eye out for. I'd say the cons to this system are going to be flexibility when it comes to upgrades and swapping things out in the future. This is a very flexible system when it comes to water-cooled systems in general. That's why I used so many quick disconnects and tried to make it somewhat easy to get in there to modulate or modify things if I need to. But at the same time, that NAS system that's down in the bottom is really wedged in there. If I wanted to do any work on that, it would be a lot of effort to get it out of there. And then I think functionally there have been two main areas of concern. One was getting it stable in the first place, and that was mainly to do with running the memory at higher frequencies. I wanted to do that, but with so many DIMMs in there, it's challenging to get it stable. I think I'm okay for right now. I might still tweak and tune it a little bit more in the future, but for the time being, as a system that I'm going to be doing most of my work on, I think it's okay. The second thing is some instability. I think that has to do with the Corsair IQ software. That's still been being developed, and they actually just did a new version of it right before I shot this video. But I've noticed, for one, that if the system goes to sleep, the IQ software just completely stops functioning. The colors change, the fans all spin at the high speed. I have to shut the system down and start it back up again. Hopefully that's something that can be fixed in the future. I've also noticed that it likes to sync up everything you have connected. So I've got my Corsair mouse right here, my M65, which is a mouse I really like. It keeps resetting it back to some default setting with really high DPI, so the mouse moves really slow. So I keep having to switch it back from that. That's kind of an annoyance, but I'll probably be able to mess with the software a little bit and figure that out. On the plus side, it has synced up the LEDs on the mouse, which I never did myself with the color scheme that I have on there. So the IQ software, I have to give it credit for being as flexible as it is to do all this stuff, but still working out some kinks in the background. Guys, let me know what you think of this video and this entire series, by the way. It's been a long time coming to get this system integrated into my workflow, but I do feel like I've done that now. So I'm going to quickly jump to some games. Let's take a look at those. The game I actually played is Apex Legends, because it's a pretty fun game right now, and I was actually loading up OBS at the same time to see if I could do 4K, 60 FPS gaming and capturing at the same time. Unfortunately, Apex doesn't seem to take advantage of SLI very much at this time, at least not with this configuration. So unfortunately, the frame rate wasn't all that great at 4K. I was struggling to hit at 60 FPS in a few situations, so I turned the settings down to medium. Beyond that, I was just messing with different OBS settings, trying X264 in order to capture 4K 60 FPS at the same time. Unfortunately, I didn't get like a perfect solution for that. I think I'm getting closer to something good. I did get one set of captures that were pretty nice, not too terribly choppy. I think this is something I might revisit in the future, just looking for the perfect settings for 4K 60 frames per second capturing while you're gaming and playing something that has a lot of movement involved. Unfortunately, the game I did the best in, because I was being carried by two other guys, is the game that did not capture very well. I was trying the new NV encoder setting, and it's very new, and it ended up being just freeze frames for most of it. But we were second to last eliminated there, and that was pretty fun. Hey, that was fun. I should game more often. I actually have been gaming more often. It's been great for mental health and everything. But moving back to this, there's one last thing that I wanted to do before I close this video. It has to do with the computer tucked over here on the left. It's connected to the monitors. The cords are too short for me to do sit-stand on this desk anymore with it plugged in that way. So all I have to do is unplug this, theoretically. There we go. And now I can do this. I should have double-checked plugs. Everything's fine? Oh, good. Everything's fine. Look, now I can stand. Except my framing's messed up now. Okay. That is going to wrap it up for this video, though, guys. Thank you so much for watching, and check out the Riptide playlist if you want to see the full series of me assembling this thing, putting it together, getting the LEDs set up, and all that good stuff. Thank you so much for watching this video. Hit the thumbs up button if you enjoyed it, and we'll see you guys in the next one.